Hi, my name is Lisa Reed Preston. Welcome to my studio. I've taught in Nashville for the last 10 years and have had the fortune of teaching science, math, STEM, and robotics. It's been one of the best experiences that I've had. But I have a secret. In addition to being a teacher and an artist, I also have a different kind of studio. Welcome to my recording studio. Before I became a teacher, I was infatuated with sound and with musicians and with all of the amazing things that they could create. So when I decided to get my first degree, it was in audio engineering. Audio engineering is really simply understanding how energy flows. Every piece of equipment in here uses electricity in some form or another. And so I thought it would be fun if today we did an experiment using electricity. During today's activity, you'll need the following supplies: a AA battery, copper wire, a 3-in-1 tool, which is this tool right here, crepe paper, construction paper, or regular paper with some coloring utensils, and these special magnets. These magnets are called neodymium magnets. Neodymium is a rare earth element, and these magnets are especially strong. So use caution because they have a very strong attraction. There are additional safety precautions in the documentation. Today we're going to be making a tiny dancer. Now a tiny dancer is nothing more than a homopolar motor. It's a direct current electric motor that produces constant circular motion. Let's get started. The first tools you'll need is your 3-in-1 tool, your copper wiring, and your template for the tiny dancer. I'm going to start by stretching out my copper wire as straight as I can, and I'm going to use about a length from my fingers to my elbows. That should be about 14 to 16 inches. I'm going to use my multi-tool to cut the wire. And now that we have the wire cut, I'm going to use the template to trace with the wire. Notice that I'm using the multi-tool to bend the wire easily. It's okay to use your hands to bend the wire as well. It doesn't have to be perfect, but your goal is to try to get it even on both sides. Once you've got the shape of the dancer, don't forget this part down here. If I flatten that out, we should have a pretty good template. Now, the next step, you're going to take your AA battery And using the battery, you're going to wrap the bottom part around. You only need to wrap it once or twice. Try to get it towards the bottom if you can. And once you've got it wrapped around, go ahead and snip off some of that extra. I like to leave a little just in case I make a mistake. I'm going to remove the battery, and now that I have this spiral shape at the bottom, I'm going to use my fingers just to open it up just a little and make sure that it's round. And voila, we have our tiny dancer. But Lisa, you say, it's not dancing. That's where the batteries and the magnets come in. Now, a battery is a very special thing. A battery is an example of chemical potential energy. Potential energy is just stored energy that's not currently in use. Using these magnets, we're going to turn our potential energy into kinetic energy in order to make our dancer move. To do that, place the negative side of the battery, that's the bottom side, and if you're not sure, you'll notice that the top with the bump has a plus sign. So we're going to take our batteries and we're going to attach them to the bottom and stand it up straight. And check your connection. Right now I'm noticing that the bottom of my copper wire is not quite making it over the batteries, and so I'm going to stretch it out just a little. Don't worry if it doesn't work the first time, that's common. You want to make sure that you get your wires in just the right place. So it should be hovering around the magnets at the bottom, not quite touching them. And your bottom coil should be looser than the actual battery itself. Once you've made your adjustments, replace it. Notice that this time I got it wide enough, but I'm still not quite touching the bottom. So I'm just going to bend that open just a little bit more. Once you've made the proper connection, you'll see your dancer start to spin. Don't be afraid to get it wrong. That's what science is all about. If you notice that it spins and then falls off, just reshape the bottom a little. Remember, it should not be hugging the battery tightly. It should be loosely around the battery and the magnets. If you choose, you can create an outfit for your tiny dancer in order to make it look like a real ballerina. To do this, you can use construction paper, crepe paper, or regular paper that you've decorated. Cut out a circle, put a slit in the center of the circle, and slide it over your copper figure. Use the hot glue gun to put a tiny dab to connect the skirt to the copper wiring. But why does this work? Well, the battery, which has the stored potential energy in it, and the magnets connected to the negative end of the battery, create what's called a magnetic field. Copper is an excellent conductor, and therefore when you place it on top of the battery and make connection with the positive end, while it has exposure to the magnetic field on the bottom, you've created a closed circuit. and that means the electricity is able to get through and cause the motion of the dancer. As in many experiments, there are a number of variables that you can change. For instance, what do you think would happen if I added a fourth magnet? Or what if I took a magnet away? Neodymium magnets don't just come in this small size, they also come in this much larger size. What kind of changes would we have to make with our experiment in order to use these larger size magnets? Let's try it. Notice that now my magnets are much larger than the bottom of my battery. So in order to accommodate this, I would have to make sure that these coils would fit around my battery. Let's try it. Oops. I can feel the motion, but it's not very steady. So I'm going to try to stretch that bottom part out just a little more. Again, you want to make sure that your dancer is directly over the center of the spiral. One of the things that I love about science, and art for that matter, is that nothing is truly ever a mistake, because it's an opportunity to experiment. I'd love to see examples of your tiny dancers. Please feel free to share them.